We've said when price changes, there is an observed response. Consumers change their consumption. In the conventional case, as long as we don't have given behaviour, if price falls, what would happen? Consumption would increase. That would be the observed response. Well, that observed response, we've said, can be broken down into its substitution effect and its income effect. Now, the substitution effect, just to reiterate what I've just said, the substitution effect looks only at the change in relative prices. The income effect looks only at the change in real income. So that's just a very simple way, not taxing, of summarising what we did in last week's lecture. Substitution effect and income effect. Algebraically, we could substitute that for the following. With delta, in all instances, we've got our deltas here, those triangles. Delta just means changing. So we've got x, which is the consumption of good x. So delta x is the change in the consumption of good x. P is price, so that's change in the price. And so that first term on the left-hand side, the way that we'd interpret that, the interpretation that I want you to put on it, is that says the observed response looks at the relationship between changes in the demand for good x, the consumption of good x, and changes in its price. That is what the observed response is. Price changes, it induces a change in consumption. That's the observed response. This next term is the substitution effect. And we can interpret it in a very, very similar way. So this says, as price changes, delta P, as price changes, what is the effect on the consumption of good x as a result of the substitution effect? And if you think about it, that is really, really straightforward. As price changes, what's the effect because of the substitution effect? Well, the substitution effect only looks at changes in relative prices. So this term here is really straightforward. If price increases, what do consumers do? They substitute away from that good that's relatively more expensive. If price fell, consumers would substitute towards the good that's now relatively cheaper. So the substitution effect is always straightforward. There is no ambiguity. In that sense, we know that the substitution effect would always be negative. I'll come on to this a little bit towards the end. But what I mean by negative is that relationship between consumption and prices. It's a negative relationship between the two. If price falls, you substitute towards it. You increase your consumption. So a negative relationship. One goes up, the other comes down, and vice versa. And that will always be the case for the substitution effect. There is never, ever any ambiguity. Substitution effect is always negative. The problem arises, though, with the income effect, and in particular, the way that I've described it here. Because if you think about it, this says, how does the consumption of good x change due to the income effect as a result of price changes? What was the whole point about the income effect? That it's independent of price changes. It looks at only the change in real income. So as it stands at the moment, there is just no way of interpreting that term there. So we've got a bit of a problem. Well, what we can do, though, is look at that term here and ask ourselves a very simple question, and that will allow us to reinterpret that income effect that I've got on the end. And the question we can ask ourselves, that if price changes, what is the change in income induced by it? That might sound a complicated question, but it's very, very straightforward. And I'll give you a simple example. Let's say that you're a supporter of Swansea City, and you go down to the Liberty Stadium to watch the Swans play 20 times a season. How much poorer would you be if the admissions, the price of admission, went up by £2 per match? Well, if you still went to see them 20 times over the course of the season, if the price of admission rose by £2, you would be £40 worse off. If you still went 20 times over the course of the season, each and every time you paid an extra £2, you're £40 worse off. That's effectively how much your income is being reduced by. And so, the change in income, delta M, using M to denote income, the change in income is X, the number of times you go to watch football, times delta P, the change in price. And I've also put the minus sign in front to denote the fact that as price goes up, your income effectively is reduced. So, if we still went 20 times, if price went up by £2 per ticket, you would effectively be £40 worse off. That would be the effective reduction in your income. Now, all I want to do is take this expression here and just rearrange it. So rearrange it in terms of delta P. That gives us that expression there. The change in price equals minus delta M over X. But look what we've got here. We've got a delta P there. We've got a delta P there. So just take this term here for delta P, which is minus delta M over X, and substitute it into there. Once you do that, it gives you that expression there. So this is our observed response. Second term is our substitution effect as before. But this last term here is now our income effect. And the way in which I've now specified it does allow us to put an interpretation on that latter term. And that expression in its entirety is known as the Slutsky equation. It's just a algebraic way of identifying, of representing our income and substitution effects. So what does that mean then? Can we interpret minus X? Well, that's just the minus times the consumption of the good. The second part there, delta X over delta M, that tells us how does consumption change as income changes. And what's that related to? That is effectively the income elasticity of demand. And we know exactly how that operates. Income elasticity of demand for a normal good is positive. Income increases, consumption increases. Income falls, consumption falls. That's for a normal good. And for an inferior good, the income elasticity of demand is negative. Consumption and income move in opposite directions. Income increases, your demand for an inferior good will fall. A negative relationship. And those bits of information now allow us to interpret precisely that income effect. That is what we'll now do. So that then was our Slutsky equation. And we're going to take three different types of goods. We'll take a normal good, we'll take an inferior good that isn't Giffen, and we'll also take a Giffen good. And just look at the income and substitution effects of these. Well, firstly, for a normal good, what about the income effect? What about the substitution effect? Well, we've already said the substitution effect is negative. As price goes up, you substitute away from it. Price and consumption move in opposite directions. So the substitution effect is always negative. For a normal good, the income effect is also negative. Now, this might seem a bit strange. Didn't I just say, for a normal good, income increases, consumption increases? Well, if income falls, consumption falls. So there's a positive relationship between the two. And yet I've said, income effect for a normal good is always negative. What are we missing here? We're missing the fact that that positive term related to the income elasticity of demand is multiplied by minus x. And a negative times a positive is always negative. And so, we've got a substitution effect that's negative, an income effect that's negative. The overall effect must also be negative. But remember what I said negative means. It means it moves in the opposite direction to the price change. So there's a negative relationship between price and consumption. What does that define? A downward sloping demand curve. If price falls, consumption will increase. That's our conventional downward sloping demand curve, made up of an income effect and a substitution effect that are both negative. But notice though the direction. For a normal good, income and substitution effects, as we said last week, move in the same direction. They reinforce one another. Hence, there is never ever any ambiguity. A negative relationship between price and consumption. That was the case of a normal good. Now though, let's look at the case of an inferior good. So for an inferior good, the substitution effect, as said, it does not change. It never ever changes. You always, regardless of the type of good, you always substitute away from a good when its relative price goes up. You always substitute towards it when its relative price drops. Substitution effect never changes. It's always negative. The income effect, though, moves in the opposite direction, as we saw with our diagram last week. Income effect is positive. And why is the income effect positive? Well, remember, that is composed of two different parts. We've got that second part of the income effect, which is related to the income elasticity of demand. An inferior good, income increases, you reduce your consumption. So income elasticity demand is negative. So that negative term there, multiplied by minus x. A negative times a negative is a positive. So there we go. For an inferior good, the income effect is positive. But notice though, it means now that the income and substitution effects will move in opposite directions. And depending upon which is larger, is it the income effect or the substitution effect, will determine whether the overall effect is negative or positive. Now in the conventional case, where we have a non-given good, we said that the substitution effect dominates. And so the negative effect is larger than the positive income effect, and so overall we have a negative relationship between price and quantity. And what does that lead to? Negative relationship, price and quantity moving in the opposite directions, a downward sloping demand curve. However, if the inferior good in question is a given good, this time the income effect is so large that it dominates. And so the overall effect is positive. A positive relationship between price and quantity. If price goes up, quantity goes up. So we have an upward sloping demand curve. And that is what defines a given good. Not the fact it's an inferior good, but the fact that it's an inferior good with an upward sloping demand curve. That would be given by that overall positive effect there. But I've done this, and that really isn't telling you an awful lot more than we did last week. Last week we did it diagrammatically, and okay, I've told you what the Slutsky equation is. I've put these negative and positive signs in there, but that doesn't tell you an awful lot different from the diagram that we use. But the reason I gave you that Slutsky equation, the reason we've been through the Slutsky equation, is I now want to show you why given behaviour is actually so unlikely to be observed. You have heard about it in the past. You would have heard examples about the potato famine during the mid-1900s, between the mid-19th century. Forget about whether this is true or not. Why is it sometimes stated that given goods can exist? So far what I've done, I've dismissed them as a theoretical curiosity. Actually, they don't exist. And from the Slutsky equation, we can see why we can be so adamant about this. And what I want to do, I want you to do, is think about what is required for given behaviour to be observed. Given everything I've told you so far, two things. One is the good needs to be inferior. That's the first thing. For given behaviour to be observed, the good in question absolutely must be inferior. Secondly, though, not only must it be inferior, but the income effect needs to be large. If it's an inferior good with a small income effect, substitution effect will dominate, and we still get a downward sloping demand curve. So it needs to be an inferior good that has a large income effect. Well, I want to touch upon this point now then about a large income effect. And in particular, that term there, that minus x, that term at the front of the income effect. Now what's going to happen as x gets smaller and smaller and smaller? That term there, x, if the amount that you spend on a good in your total budget gets smaller and smaller, that's what x getting smaller means. And if x gets smaller, just the product of x times that second term there, as x gets smaller, the income effect gets smaller. And if you think about it, that's entirely sensible. Let's say that you go over to Tesco's to buy something, and you see that the price of salt in Tesco's has doubled. Is that going to make you feel any poorer? Doesn't really matter. Your consumption of salt is going to be such a small part of your total expenditure that even if the price of salt doubled, would you feel inherently poor? Simple answer is no. But what would happen if you got back to your house tonight, the landlord came around, knocked on the door and said, I apologise, but I've got to tell you, your rent has now doubled. Would that make you feel, I'm not going to say this would happen, but let's say it did. Would that make you feel poorer? Of course it would. Because rent is a large part of your overall budget. So I think, what does this mean? What does this mean then about given behaviour? Well, for the income effect to be large, it requires us to be talking about goods that form a large part of consumers' total expenditure. But these also need to be inferior goods. So those are the two requirements. If we don't have both of those, we're not going to get given behaviour. And then, by extension, what about those goods in modern budgets? which are those that form the large part of consumer expenditure. They are things such as housing and transport. And absolutely, all empirical studies will tell us housing and transport are normal goods. They are not inferior goods. There will be lots and lots of things that you spend your money on that are inferior goods. But they won't be components that form a large part of your total expenditure. Hence, that's what we get from the Slutsky equation that we didn't see previously from that diagrammatic representation. Yes, theoretically, it's possible for given behaviour to exist. It's possible theoretically for demand curves to slope upwards. In practice, though, this Slutsky equation tells us why it's highly, highly unlikely. Those goods that consumers nowadays spend a large part of their budgets on absolutely are not inferior. And as such then, that's going to be why given behaviour is so unlikely to be observed in practice. The last aspect of this topic of consumer choice and that is looking at the idea of what we will call intertemporal choice. Looking at consumption decisions over time. Now, when you've studied the theory of consumer choice before, you had a budget constraint, and the implicit assumption, everything that you go through, was the consumer chooses a point to consume along the budget constraint. That they have a certain income, and they allocate all of their income to one of two goods. They spend everything, that they don't save at all. Well, what we're going to do now is look what happens when consumers are allowed to save. We think what happens in practice. The very fact that you choose to consume less today, i.e. you save, means that you can afford to consume more in the future. So, savings and consumption decisions absolutely do have a temporal dimension. These decisions are taken jointly and they're taken over time. So as soon as we start realising this, we move away from that theory of consumer choice that you would have seen in your first year, and we move into the topic of intertemporal choice. Now, the basic setup of what we're going to do doesn't change an awful lot. Well, the details change, but the overall framework and the essence of it, the way that we build it up, doesn't change. What we're going to do is define a budget constraint. But not a budget constraint that you would have seen before, but rather an intertemporal budget constraint. And given this budget constraint, what will the consumer want to do? Consumers will want to be somewhere along this budget constraint such that they maximise their well-being, such that they do what's best for them. Well, we then need to say something about the consumer's preferences, their intertemporal preferences. And then when we bring those two together, that's when we find our equilibrium outcome. So that's the basic setup, the same sort of basic setup as you would have seen with the theory of consumer choice previously. Well, we're not going to deviate a million miles from that. But there are very, very important details that are different between these two. So, to start us off then, what we'll do is look at the intertemporal budget constraint. And we'll say that consumers have to decide, have to allocate their income between two periods, choose how much they spend in two different periods of time. And these two time periods are the present and the future. So individuals have income in the present and the future, and they need to decide, well, how many goods, how much do I want to consume in the present and the future? So that's then the starting point. So what we have here is a very simple diagram, and we are representing consumption in the present along the horizontal axis. So we will say consumption in the present, we'll denote that by C0. And on the vertical axis, we will denote consumption in the future. Now, whatever the future means, it's not the present. So consumption in the future, and that will be C1. But rather than talking about consumption of individual goods, we'll talk about these composite of all goods. So our consumption, C0, is the consumption of all goods in the present. Our future consumption, C1, is our consumption of that composite of all goods in the future. So that's what we're trying to define. How does a consumer allocate his consumption between the present and the future? Well, the starting point to think about this, and I've already touched upon it, is how does this consumer spend the income in these two different time periods? Well, we're not going to worry about where consumer income comes from. We'll just say that this consumer has a certain amount of income in the present, and that income in the present will denote by M0. Our consumer also has income in the future, and we'll denote that by M1. That defines the consumer's initial endowment. That's our consumer's endowment of income. If we assume that the prices of current and future consumption are both 1, that means an income of M0 allows consumption in the present of M0. And income in the future of M1 allows consumption in the future of M1. So that's the starting point. Our consumer has a certain amount of income in the present and future. How, though, do they allocate that income towards consumption in the present and the future? Well, think about it. You've got a certain amount of income in the present. Do you have to spend all of that income in the present? Or could you perhaps save a little bit and put whatever you save towards consumption in the future? Or might you say, well, I'm going to have an income in the future and I would rather increase consumption in the present. So you borrow money, you take out a loan. All of these possibilities are traced out by a consumer's intertemporal budget constraint. And the rate at which you can either save or borrow is determined by the market rate of interest. Now, for simplicity in what follows, we'll say that the market rate of interest, which we'll denote by the letter R, is exactly the same for saving and borrowing. Now, in practice, it isn't, and it's easy enough. If you wanted to, you could change it. But all it does, it makes the diagram a little bit more messy. And there's no need to do it. It adds nothing to understand it. So we'll just say that the rate of interest at which individuals can both save and borrow is exactly the same. And we'll denote that by the letter R. I should say, though, and this will probably avoid confusion a little bit later on, the rate of interest R, we're going to take that as a proportion between 0, in all cases, as a proportion between 0 and 1. So, for example, if the rate of interest was 10%, R is 0.1. If the rate of interest was 100%, R would be 1. If the rate of interest was 5%, R would be 0.05. That's the way in which we're going to interpret the rate of interest. So, given that then, given this common rate of interest, this line here, running from point A on the far left, all the way to point B, and going through the endowment point, that denotes our consumer's intertemporal budget constraint. And all it does it traces out all the possibilities that a consumer has to substitute consumption in the present and the future. Now, obviously, there's a trade-off, because the more you consume today means the less you can consume tomorrow, and vice versa. And all of these trade-offs are denoted by that straight line there, intertemporal budget constraint. Now, if we were at point E, what would it mean? If we're at point E, it means that the consumer has a current income of M0, and he would choose to consume M0 in the present. So whatever he has, he spends. But what I want you to think, though, is what it would mean if we moved from the endowment point up the budget constraint towards point A. As we trace along this budget constraint, what's happening to current consumption? Current consumption here. If you move up the budget constraint, current consumption is falling. It's decreasing. So that consumer has a certain amount of income, but he's spending less in the present than his income. And what's he doing with the rest of it? He's saving it. So any point on this budget constraint between point B and point A, anywhere to the left of the endowment point, means that the consumer is saving. And obviously, the further to the left we move, the higher the level of savings, until eventually we'd arrive at point A, where the consumer in the present is consuming absolutely nothing. He's putting all of his present income into savings and converting it to consumption in the future. So anywhere between E, endowment, and A, anywhere along that part of the budget constraint, the individual is saving. Now, what I want you to think about, if the individual saves in the present, how much does he get back in the future? Well, I'll use a bit of notation first of all, and I'll give you a very, very simple example with some numbers in it. So if the individual saves S pounds in the present, in the future, what does he get back? Well, if you save S pounds in the present, you get that S pounds back, plus you also get the return upon that S pounds. And that is determined by our rate of interest times the S pounds. So you get S plus the return on S. It simplifies to merely 1 plus R times S. That's the total return upon savings. If you save S pounds, in the future you get 1 plus R times S pounds. So just to put some numbers in there for you, let's say that you saved £100. So that is our estimate. You're choosing to save £100. Well, the rate of interest is 5%. So in terms of how we specified R, remember, I said it's a proportion between 0 and 1. So if the rate of interest is 5%, that means R is 0.05. How much will you get back? £100 is a 5% return on that. You get back £105. So that's 1 plus 0.05, which is 1.05 times 100. There you go. So that is the total return on savings. So every S pounds that you save, you get that amount back. So that then is what the return on savings are. So think, what does that mean, the slope of this budget constraint is equal to that? Well, it means that if the budget constraint is a straight line, it's got a constant slope. So for every S pounds that you save, you get, in the future, your return upon savings is 1 plus R times S. So you go down S pounds, you go up 1 plus R times S pounds. Now, what is the slope of any line? The slope of any line is just the ratio of the rise over the run. How much do you go up? That's the rise. How much do you go along? That's the run. So we've just said, if you go up 1 plus r times s, you will go along s. And I put minus s in. You can see here, consumption is falling by that amount. Consumption falls by that amount, s, in the present. It goes up by that amount in the future. And so, the slope of that line, you see these s's drop out, so the slope of that line is minus 1 plus r. That's the slope of our intertemporal budget constraint. Now, I've already mentioned this point here, A. I've said that's the maximum amount of future consumption. That's what would happen when the individual chose to save everything in the present and convert it to consumption in the future. Well, that point A also has a very special name. That's known as the future value of the endowment. So the endowment for the individual is worth a certain amount of income in the present and a certain amount of income in the future. Well, what would happen if the individual said, I don't want any consumption in the present, I'm going to convert it all to future consumption? Well, that's what we get at point A, the future value of the endowment. And if we wanted to calculate it, that is what it would be. 1 plus r times m0 plus m1. And just to think about intuitively, why is it that? Well, think. What is the future value of the endowment? It's the maximum level of future consumption. And what's that determined by? It's determined by future income, which is M1, plus also saving and its return. And how much are we saving here? We're saving M0. And so the total return is 1 plus r times M0. That is saving and its return. That is future income. And that is the maximum level of consumption in the future. And that is known as the future value of the endowment. Any point to the left of the endowment point reflects a situation where the individual is saving. That means that their current consumption is less than current income. They're saving. In contrast, anywhere to the right of the initial endowment point, if the individual chooses to consume somewhere along the budget constraint, anywhere between the endowment point and point B, on the far right-hand side, it means that the individual is borrowing. That is, that their current consumption is greater than their current income. And how can they consume more than the income coming in? By borrowing money. And they borrow that money on the back of their future income. So, how much can you increase current consumption? Well, again, I'll give you just a notation and then I'll give you a very, very simple example again. If you choose to borrow in the present to finance an increased level of consumption, it means in the future you need to repay that loan. You need to repay that loan with interest. So if you borrow B pounds in the present, in the future you pay back not just your B pounds, but also the interest repayment on the B pounds. That is R times B. Simplify that to 1 plus R times B. So every B that you increase your current consumption by means that you must reduce future consumption by 1 plus R times B. And just to give you a very, very simple examples, and mirroring the one we saw previously, if you borrow £100 in the present, so that's B. If the rate of interest is 5%, that's our R there, so that's B, that's R. In the future, you pay back not £100, but £105. That's the initial loan plus the 5% interest. So that is just where that is coming from. That's the total repayment in the future. So if you want to increase consumption in the present by £100 by borrowing money, in the future you need to reduce consumption by £105. That's all that we're saying. So in terms of the slope of that budget constraint, it's a straight line, so that slope needs to be exactly the same. But just to prove it and show you what we're going through. If you want to increase consumption in the present by £B, it means that you must reduce consumption in the future by 1 plus R times B. And so, again, the slope is the ratio of the rise over the run. The ratio of 1 plus R times B over V. So again, the slope in absolute terms is 1 plus R. But again, it's a straight line, so it has to have the same slope. So that's what happens as we increase consumption, and that will continue until we arrive at point B. Now at point B, it means that we're borrowing as much money as we possibly can. It means we've got our current income and we're supplementing that with the maximum size of loan we can possibly afford. But that maximum loan that you can afford is constrained by something. It's constrained by your future income. If you think about it, if you had a loan that had a total repayment in the future, you need to pay back £12,000. Well, who would give you that loan if in the future all you could afford to pay back was £10,000? You see, the maximum loan that you can take out and its total repayment cannot exceed your future income. So the future income constrains the maximum loan repayment. So, 1 plus R times B, we said that previously, 1 plus R times B, that was the amount that you repay in the future. So the maximum amount that you can take out, just denoted here by B max, is 1 plus R times B max. That's the maximum repayment that you can afford. And that, at the margin, is constrained by your future income M1. If your future income is £12,000, the maximum you can repay in the future is £12,000. It can't exceed that. So that is the absolute limit of your ability to borrow money. And if we just rearrange this expression here ever so slightly to this, that is the maximum loan that anybody could take out. It's your future income, M1, divided by 1 plus the rate of interest. That's the maximum loan you could possibly afford. And now what I want you to do is think that point B on the diagram, that point to the far right, that was the maximum level of present consumption. And what is that determined by? That maximum level of current consumption is determined by your current income, which is M0, plus the maximum loan that you can take out. What is the maximum loan? M1 divided by 1 plus R. And hence, as we go all the way along to that point there, the absolute maximum amount that we can raise current consumption up to is determined by current income plus the maximum loan. And that point B in the diagram, the sum of those two, current income and maximum loan, is known as not the future value of the endowment, but rather the present value of the endowment. And there you go, that's what it's equal to. M0, which is current income, plus M1 divided by 1 plus R. Where that second component is the maximum loan that you can take out. And that then describes our intertemporal budget constraint. However, there are three components of that intertemporal budget constraint that are influenced by the rate of interest. We've got the present value of the endowment here, which is influenced by 1 plus R, the rate of interest. We've got the future value of the endowment, which is also influenced by the rate of interest. And lastly, what's the slope of that budget constraint? Minus 1 plus R. So hopefully it should be fairly obvious that if the rate of interest changes, increases or decreases, those three components will also be affected. The present value, the future value of the endowment, and also the slope of the budget constraint. So, that's just to remind you what these future and present values were. Just want to say, well, what would happen to each of these components as the rate of interest increased or the rate of interest decreased? Now, we'll concentrate upon this one first of all, increase in the rate of interest, and decrease is just the reverse. So, what would happen to the future value as the rate of interest went up? Well, that's the future value here, and if the rate of interest goes up, the future value is going to also increase. Do you think what the future value is? That's your future income plus your savings and its return. Well, if the rate of interest goes up, your return on savings increases. And so, the future value will increase. If, though, the rate of interest increased, and we looked at the present value, what's going to happen? Well, remember, if we're dividing by a bigger number on the bottom, the value is going to fall. Think about it intuitively. What is the present value of the endowment? It's determined by current income plus the maximum loan that you can take out. But if the rate of interest is going up, what does that mean about the maximum loan that you can take out? It will fall. Hence, the present value will decrease. It will also fall. And that is what will happen for an increase in the rate of interest. And what will happen to the slope? The slope, the rate of interest goes up, will get steeper. The slope was minus 1 plus R. So in absolute terms, increase in the rate of interest, that line becomes steeper. And then when we look at a reduction in the rate of interest, I won't go through this, rather than just putting the values on, it's just completely the reverse. The future value will fall for reduction in the rate of interest, and the present value will increase for reduction in the rate of interest. Purely the reverse of those scenarios we went through, and if the rate of interest falls, the slope does what? It becomes shallower. So it's those three bits of information. What happens to the slope? What happens to the present value? What happens to the future value? I want you to hold in your mind. So that was our intertemporal budget constraint. What happens if there's an increase in the rate of interest? I see you looking at the diagrams and handouts, we're not quite there yet. So, for an increase in the rate of interest, we said that three things will happen. Firstly, we said the future value will go up. So the future of the value of the endowment, which is there, on the far left of the budget constraint, increases. Rate of interest goes up, the return you get on savings increases. So the future value goes up. We also said that the present value of the endowment, that point on the far right, will fall. Rate of interest goes up, maximum loan you can take out declines. And so the present value will also fall. And lastly, we said what happens to the slope of the budget constraint? It gets steeper. If you put those three facts together, that is what happens to the intertemporal budget constraint following an increase in the rate of interest. It becomes steeper, but it pivots about the initial endowment point. It does not, for example, do that. It does not pivot about the axis. It's completely wrong. It pivots about the initial endowment point. So that is an increase in the rate of interest. Very quickly then, what about a reduction in the rate of interest? Well, we said that the future value will fall, goes down. We said that the present value will increase, goes out, and we also said reduction in the rate of interest, the slope of the line becomes shallower. Put those three together, and there you go. That is what the intertemporal budget constraint would look like if the rate of interest fell. It becomes shallower, pivoting through the initial endowment point. And if students make a mistake with this in exams, it's this part here. They don't show that pivot through the initial endowment point. Now, it doesn't matter what the rate of interest is, that initial endowment point should always be available. If you make sure that it pivots, or if you drew it such that it pivoted about one of the axes, is that initial endowment point still available? No. The endowment point must always lie on the budget constraint. After all, a consumer should always have the option, if they want to neither save nor borrow. So the endowment point must always run from, or the budget constraint must always run from the initial endowment point. And that's the one mistake that most people make in an exam. And if you attempt a question like this, intertemporal choice, in an exam, and you get the budget constraint wrong, everything else that follows from that is wrong. So, the endowment point should always be available. So that then is the intertemporal budget constraint. What happens then when we bring the budget constraint together with the preferences of consumers? Well, the way in which we've set this up so far is that there's consumption in the future, there's consumption in the present. And there's no reason why we can't treat these two composite goods like any other good. And we can represent the consumer's preferences for current and future consumption with a standard set of indifference groups. So given that then, what would the consumer want to do? For a given rate of interest, that determines the slope of the budget constraint. For initial level of income in the present and the future, that determines the initial endowment point. Where along that budget constraint does the consumer wish to be? Where the consumer is on the highest possible indifference group. So if we represented consumption in the present and future with a conventional set of indifference curves, if this highest possible indifference curve was at a point such as S, if that is to the left of the initial endowment point, that means this consumer, given his tastes and preferences, he would like to be a saver. He wishes to consume MS in the present and a certain amount in the future. But crucially, where he wants to be means that his current level of consumption, MS, is less than his current income. So what's he doing? His distance between MS and M0 is what he's choosing to save. So this person, at that point of tangency, is to the left of initial endowment point. He is choosing to be a saver. And that distance between the endowment point and point S is the level of saving. And naturally, the further left we are away from the initial endowment point, the further left this point of tangency is, the higher the level of savings. Conversely, if the consumer's preferences were such that that point of tangency between the budget constraint and highest possible indifference curve was a point such as B, and point B is to the right of the endowment point, this person wishes to be a borrower. That is, his current level of consumption is great MB is greater than his current level of income. And where's that extra consumption coming from? He's borrowing. He's taking out a loan. So, that would depict the situation of a borrower. And naturally, the further to the right we go, the further away from the endowment point, the higher the level of borrowing. And then lastly, what would happen if that point of tangency occurred at point E? Well, then this person would be neither a saver nor a borrower. In the present, he's choosing to consume exactly the same as his level of income. So he's neither saving nor borrowing. So that then integrates these two aspects that we talked about, the budget constraint and the preferences. Now, given what I've said, it should be fairly obvious to see then that if there's a change in the rate of interest, that will affect the budget constraint. And likewise, if there's a change in the budget constraint, that will change where our consumer will optimally be. Will they remain a saver? Will they remain a borrower? Well, that's what we're going to do for our last part. However, I'm only going to run through the case of how a change in the rate of interest affects a saver. So in the main text, the Morgan, Katz and Rosen, they don't do the case of a borrower, and hence, as I said at the beginning of the lecture, I don't want to run through this just for the sake of it. So those diagrams that are all on the back, and that text that goes with it, we're not going to do it. We're only going to do, and this is the last thing we're going to do for today, we're just going to go through that one diagram that remains. And that is what happens to a saver when the rate, and we're only going to look at one scenario, we're going to look at what happens to a saver when the rate of interest increases. Now, in terms of logistics, as I've done before, all the things I'm going to put on the web blog and the slides and the video capture, etc., it will exclude any reference to a borrower and the rate of interest changing. Only going to be the case of a saver. And that's the only thing that you find in the text, Katz and Rosen. Morgan, Katz and Rosen. Now, in many ways, the saver actually is the more straightforward case. So we're going to look what happens when there's an increase in the rate of interest on the behaviour of someone who is a saver. However, and this is important, later on we're going to look at income and substitution effects. The text, Morgan, Katz and Rosen, doesn't go through income and substitution effects. When were you to look at a reduction in the rate of interest, it isn't just the opposite. So, what I'm going to do, I'm only going to do an increase in the rate of interest, and in your exam, I would not do the case of a saver when the rate of interest falls. Okay? Absolutely not going to do it. The only thing I would test you on is what I do in this lecture today. So for a saver, only an increase in the rate of interest. The decrease in the rate of interest isn't just the reverse, it is more complicated. But just what I do in lectures is what I would expect you to know for your exam. So, this is our diagram. That B1 is the initial intertemporal budget constraint. Point E is our initial endowment. So given the initial budget constraint, where does the consumer wish to be? Well, the consumer wants to be on his highest possible indifference curve, subject to that budget constraint. And that highest possible indifference curve is indifference curve U0. And that just touches our budget constraint B1 at point A. And because point A is to the left of the endowment point, it means that current consumption is less than current income. So this person is a saver. So that's the starting point. Then there is an increase in the rate of interest. So an increase in the rate of interest means that our budget constraint pivots about the initial endowment point and becomes steeper. So it then becomes that steeper budget constraint B2, that one there. And then what does the consumer do? Well, the same as before. Our consumer wants to be on his highest possible indifference curve, subject to that new budget constraint. And the highest possible indifference curve he can reach is that indifference curve U1 that just touches our new budget constraint at point C. So what does that tell us about the saver? Well, it tells us two important things. Firstly, following an increase in the rate of interest, a saver will always, no ambiguity, will always remain a saver and will always be better off. That absolutely never, ever changes. And that's what we saw from the previous diagram. I'll put that definition in front. Is that person still a saver? Is he still to the left of the endowment point? Yes. Is he better off? Yes. He's on a higher indifference curve. So we've ticked both of those boxes. And that will always be the case for a saver affected by an increase in the rate of interest. You will always remain a saver, and you will always be made better off. Never ever changes. And that is a hard and fast rule. Will always be the case. Always save, always better off. Everyone finished copying that down? So, always remain a saver, always better off. So, I'm going to quickly get you to use your phones and our Kahoot things. What I want to know, that person of savings increased or decreased? We say the further to the left you move, that savings increases. So the further away from the endowment point you go, the more you save. As this person goes from point A to point C, is he further or closer to the endowment point? He is closer. So initially, that was your level of current consumption. Now, at point C, current consumption is more. You're moving closer to the endowment point. So this movement from point A to point C, this person's level of savings has decreased. So those who got it right, well done. For those who didn't, don't worry, learn from it. We're moving closer to the endowment point. Here's the endowment point. Point C is to the right of point A. It's closer to the endowment. Hence, savings are falling. Savings are measured as that horizontal distance on current consumption. So, this person, following an increase in the rate of interest has decreased his level of savings. Now, whilst I said that the case of a saver was straightforward, in some instances, this saver will always remain a saver. This saver will always be better off. Now, what I'm showing you here is a scenario where the saver is saving less. However, that is not guaranteed. This, which we've all got them, it's quite a complicated diagram. This is where the handout comes to play. Question I want to ask you, well, is it always guaranteed that the saver will save less? To answer that, if it was a straightforward question, I wouldn't be going through this diagram. Because what a saver does, whether he increases or decreases his savings, depends upon this, goes back to what we touched upon last week and at the beginning of today's lecture. This depends upon the relative magnitudes of the income and substitution effects. So, what the diagram you see in front of you on the handout is, this is just a cutaway of the left-hand side of the diagram. The first diagram I showed you, the budget constraint extended to the right beyond the endowment point. I've just not bothered putting it in there, because we know this person never switches to becoming a bond. So I've only concentrated upon this left side after the endowment point. Just make it nice and big and clear. This was our budget constraint B1. This was our budget constraint B1. Then there was an increase in the rate of interest, and the budget constraint pivoted and became steeper. Where we end up, though, on that new budget constraint, and I've given you 3 examples, point C1, C2, or C3, where exactly we finish up will determine whether savings have increased, decreased, or stayed the same. Now, the scenario that we ran through previously was we went from point A to a point such as C3. And I'll come back to this in a moment. What I noticed when I was putting this together, of all the years I've taught this, it only suddenly occurred to me when I was putting this together last night that there is the potential for confusion. So all these years, I've asked questions to the examiner, students have made a mistake, maybe it's down to me because I've confused them with my notation. If that's the case, retrospectively, I apologise. What I've got here is a point C1. Don't confuse that with our future consumption C1 there. It's very, very bad notation on my part, but after I'd copied 200 handouts and put the notes on Blackboard, I wasn't going to then go and change it again. But please don't confuse that point C1 in the diagram and C1, that's our level of future consumption. If I refer to C1 here, I'll say point C1. I'm sure it won't cause confusion. So, there's an increase in the rate of interest. What we saw initially as we moved from point A to a point such as C3, where C3, we said, is closer to the endowment point. So that movement from A to C in the previous diagram is actually that movement here, that's you again, is A to C3 there. We're closer to the endowment point, and so savings falls. Now comes the part, well, what about the income and substitution effects? Or how would we identify the substitution effect? Well, to throw back at you that quote that I gave all the time, that substitution effect is the rotation about the initial indifference curve caused only by the change in relative prices. That rotation about the initial indifference curve. We know as prices change, or rates of interest change, there's a change in relative prices. But there's also a change in real income, in the purchasing power of the consumer's income. You only want to look at the change in relative prices for the substitution effect. And the way that we do that is we take a hypothetical budget constraint, that's got a slope equal to the new budget constraint, that this hypothetical budget constraint just touches the initial indifference curve. So that hypothetical budget constraint that has the same slope is that budget constraint there, B3. And that hypothetical budget constraint just touches the initial indifference curve at point B. And that movement from point A to point B is the substitution effect. So the overall effect is A to C3. But the substitution effect is A to B. And if you think about it, what's it done? It's moved us around the indifference curve, but think about it intuitively. This consumer is choosing to consume less in the present. From A to B, current consumption is falling. Why is the consumer doing that? Because current consumption is now relatively more expensive. The rate of interest has gone up, so everything that you choose to consume in the present would mean you'd have to give up more in the future, because the rate of interest allows you to consume more in the future. So it's that opportunity cost. Current consumption is now relatively more expensive. For everything you now consume in the present, you would give up even more in the future, because savings attracts a higher return. So what does the consumer do? Substitute away from the more expensive good. And that's what he does. Substitute away from current consumption. That is a substitution effect. So that movement, A to B, is a substitution effect. You substitute away from current consumption and towards future consumption. Well, if that's A to B, it's a substitution effect. What's left, B to C3, must be the income effect. Now look at the actual budget constraint the consumer faces, that line there I'm tracing out, and the hypothetical budget constraint. The hypothetical budget constraint is drawn closer to the origin. So as we go from the hypothetical budget constraint B3 out to the actual budget constraint, the consumer's income is increasing. Now, there's an implicit assumption here that both current and future consumption, these composites, are normal goods. Because if we're bundling all goods together, they've got to be normal. Over time, what happens as economies expand, as incomes increase? Do we suddenly find that we consume less and less and less goods? No, we increase our consumption of all goods in the aggregate. So all goods in the aggregate must be normal. So, income is increasing if that budget constraint is shifting outwards. If current and future consumption are normal goods, what happens to their consumption? They would increase. So compare point B and C3. What's happening to current consumption? It is increasing or decreasing? Exactly, well done. It's increasing. C3 is to the right of point B. What's happening to future consumption? Increasing or decreasing? Future consumption measured on the vertical axis. C3 is above B. Yeah? So B to C3, current consumption increases, but also future consumption, which is what we expect, because they're both normal goods. So, B to C3 is the income effect. And you can see they move in opposite directions. And this is what causes the ambiguity. However, I've mentioned point C3 as one possibility. What would happen if a point of tangency occurred at C2? Well, if our overall movement was A to C2, what's happened to the level of savings? Nothing. A and C2 both depict exactly the same level of current consumption. And so, what's happened to savings? Nothing. It's the same before and after the change in the rate of interest. This time, the substitution effect is still A to B. Income effect, this time, is B to C2. So substitution effect reduces current consumption. Income effect increases current consumption. But under this scenario, income and substitution effects, they move in opposite directions, but they're exactly equal in magnitude. And so the net change is zero. Nothing happens to savings. And then lastly, what about point C1? This is the confusing one. What about point C1 on the diagram? Well, here we start off at point A, and then the highest possible indifference curve just touches our new budget constraint, not at C3, not at C2, but rather at point C1. So the observed effect is A to C1. And this now means that savings are increasing. Look, between E and A is savings. However, when we go to point C1, we're moving further away from the origin. As we move further away from the origin, savings increase. What about the income and substitution effects? Well, A to B is a substitution effect as before, and now B to C1 is the income effect. This time, though, the substitution effect that reduces current consumption is less than the income effect that increases current consumption. And so the substitution effect dominates. And it's this ambiguity. Does the substitution or income effect dominate? Depending upon which is the larger, determines whether savings would increase or decrease. So back to our hard and fast rule. Savings, a saver affected by an increase in the rate of interest will always remain a saver. That saver, who remains a saver, will always be better off. But whether they save more or less will depend upon the relative magnitudes of the income and substitution effects. I think I've got just about enough time to ask you this question. When we started off today, we looked at the Slutsky equation. And we said, Slutsky equation, what do we know about normal goods? That the income and substitution effects move in which direction? They move in the same direction for normal goods. Now, I just said what we got here, current consumption and future consumption, they're both normal goods. And yet I said the reason we get this ambiguity is because income and substitution effects move in different directions. So it doesn't quite tally with what I said at the beginning of the lecture and what I've just said there now. So obviously something's not quite right. And what isn't quite right is the fact that what we're talking about here, what is new in this last part of the lecture, is it's an endowment good. And the Slutsky equation that I gave you previously does not apply to endowment goods. And for the last thing, Dave, I'll get you just to think about and answer this question. Let's say that you were the consumer of apples. That's one of the things that you buy. And the price of apples increases. Are you worse off or better off? What's it going to be? Price of apples goes up. You're a consumer of apples, you are worse off. Yep, that's fine. What would happen though? Exactly the same, the price of apples increases, but you are the owner of an apple orchard. The price of apples increase, you are not worse off, but rather you are better off, because you've got an endowment of a good that changes. And that's what we've now seen in this intertemporal framework. The price of your endowment has changed. And that's what causes income and substitute effects to move in opposite directions.